Hello YouTube family, welcome. How to solve this nice exponential equation, which is 8 raised to power a is equal to 60. How do we solve for the value of a? Now solution from here, we have 8 raised to power a, this is equal to 60. So we introduce the natural logarithm of both sides. So we have log 8 raised to power a, this is equal to log 60. Okay, so from what we have here, log 8 raised to power a, applying the power rule property of logarithm, that is log m raised to power n. This is the same thing as, it can be expressed as n log m. Okay, so applying this property, we're going to have a log 8, this is equal to log 60. Okay, so we divide both sides by log 8 by log 8. Okay, so if we simplify here, a is equal to log 60 divided by log 8. Okay, now from what we have here, 60 can be expressed as, this is the same thing as 15 multiplied by 4. Okay, so now from what we have here, we can express this as log, this is 15 multiplied by 4 divided by log 8. Okay, the same case, we can express 8 as 2 raised to power 3, and we can express 4 as 2 raised to power 2. Okay, now from what we have here, this is the same thing as log, this is 15 multiplied by 2 raised to power 2 divided by, this is log 2 raised to power 3. Okay, so let's proceed from here. Now from what we have here, a is equal to log 15 multiplied by 2 raised to power 2. Now log 15 multiplied by 2 raised to power 2, this is in the form of log a multiplied by b, which we can write as log a plus log b. Okay, so let's apply this property, so that now from what we have here, this is the same thing as log, this is 15 plus, this is log 2 raised to power 2, this divided by log, this is 2 raised to power 3, and the same case here, divided by log 2 raised to power 3. Okay, applying the logarithm property, that log m raised to power n, this is equal to n log m. So applying this property, we're going to have here, this is log 15 divided by, now we have log 2 raised to power 3, we can express this as 3 log 2 plus 2 log 2 divided by 3 log 2. Okay, now from what we have here again, we will simplify here, we're going to have log, now 15 can be expressed as 5 multiplied by 3. So we have 5 multiplied by 3 divided by, this is 3 log 2. Okay, plus this is now 2 over 3 after we simplify here. Now from what we have here, log 5 multiplied by 3, applying this property, applying the property that log a multiplied by b is equal to log a plus log b, applying this property, we're going to have log 5 divided by 3 log 2 plus log 3 divided by 3 log 2 plus 2 over 3. Okay, now from what we have here, this is the same thing as a third. Now log 5 divided by log 2, this is in the form of log a divided by log b. So we're saying that log 5 divided by 3 log 2 and log 3 divided by 3 log 2, this is in the form of log a divided by log b, which we can transform as log a to base b. Okay, so applying this property, we'll have a third log 5 to base 2 plus a third log 3 to base 2 plus 2 over 3. Okay. Now from what we have here, we can write a as equal to, remember a third is common here, so as a third, okay, into the bracket we have log 5 to base 2 plus log 3 to base 2, okay, plus 2. That's what we have. Now, which we can write this as a third. Into the bracket we have 2 plus log 5 to base 2 plus log 3 to base 2. This is the value of a. Okay? So this is the value of a. So let's verify that this value of a satisfies the equation. Okay? Now let's verify that this value of a, as you can see, satisfies the equation. Now, as you might recall, we end at 8 raised to power a. This is equal to 60. Okay? So let's substitute the value of a. We'll have 8 raised to power a third. Now into the parentheses, we have 2 plus log 5 to base 2 plus log 3 to base 2. All of this is supposed to give us a value of 60. Okay. Now we can express 8 as 2 raised to power 3. So let's substitute this back to the equation. We'll have 2 raised to power 3 multiplied by a third. Now into the bracket we'll have 2 plus log 5 to base 2 plus log 3 to base 2. This is equal to 60. We're supposed to get a value of 60. Now let's simplify here. We'll have 2 raised to power. Now here we have 2 plus log 5 to base 2 plus, this is log 3 to base 2. This is supposed to give us a value of 60. Okay. Now from what we have here, 2 raised to power 2 plus log 5 to base 2 plus log 3 to base 2. This is actually in the form of a raised to power m plus n, which we can express as a raised to power n multiplied by a raised to power m. This is indices identity. So let's transform in this way. We'll have 2 raised to power 2 multiplied by 2 raised to power log 5 to base 2 multiplied by 2 raised to power log 3 to base 2, and this is supposed to give us a value of 60. Okay. Now as you can see, 2 raised to power 2 or 2 raised to power 2, this is the same thing as 4. Okay. Multiplied by 2 raised to power of 5 to base 2 and 2 raised to power of 3 to base 2. This is in the form of m raised to power log a to base m, which is essentially equal to a. Okay. So applying this property, we will have 2 raised to power log 5 to base 2. This is the same thing as 5. And 2 raised to power log 3 to base 2. This is equal to 3. Okay. So let's substitute 5 and 3 back to our equation. Now we're going to have 4 times 5 times 3. This is supposed to give us a value of 60. Okay. Now this is 4 times 5, which is 20 times 3, which is equal to 60. And that verifies that the value of x, which